plus C. And what is this? Right. What is this? This operator means bit shift. So it means shift to the right for 16 bits. This is bit N. Let me explain it in the next slide. So this is the code. 2 lines. In the beginning, let's assume the CD is 1. We assume that. Then we execute this code. R will become this number. L means long integer. L is long integer, so don't look at L. If 1 multiplied by this number and added by this number, we are going to get this number. Clear? All clear, right? Then we convert this number into hexadecimal. It will be equal to 41C67E86. Okay, now we execute this line. In this line, the double and UINT thing are just for type conversion, so we don't need to be concerned about that. So the first thing we see is bit shift 16. 16 digit is equal to 2 bytes. So this one, shift to the right 16 is equal to discarding these bytes. So the result will be 41C6. Okay? And this 41C6, if converted to binary, is equal to this string. Then we end 0x7FFF. 0x means it's hexadecimal, so we discard this. It's actually 7FFF. 7FFF is equal to this 1 and a lot of 0 and a lot of 1s. If something is being ended with this one, the first digit will be discarded. The first digit will be discarded. What does that mean? What does that actually mean? This is a division. So if your number is, if this digit is 1, that the result will be, then only this part will be remaining. If this is 0, then still this part remaining. So this means no matter which digit, which number this digit is, it will always be 0. And this digit is indicating 2 to the power of 16. Right? This digit is 2 to the power of 16. And this digit is discarded. This is the same thing as module, the modulus operator. This is divided by 2 to the power of 16. Then the result will be 4166 still. And it's equal to this number in decimal. And if we divide it by this number, this 7FFF plus 1.0 is equal to A000 plus 0.0. Right? Divide this, and we get this output.
Aren't there easier way to implement the code like that? Like where you have to do it this way? There are easier ways to do it.
Yes. But this has a high efficiency because
very high efficiency.
High efficiency. Because in a computer it's much easier to do this than doing a division.
But it's like assembly language in a sense.
Yes. But this part of code has been executed like millions of times. So they optimize this, so it's very difficult to understand. So although they have only 2 lines, it will be difficult for you to understand it. And one thing you have mentioned is this right shift. This right shift, 16, and they divide it by 2 to the number of 16, actually means they have a precision only for 16 digits. And why they do this is because something I mentioned, in LCG, the lower bits are repeating themselves much more quickly. So they discard these bits. So this is a variation of LCG, not a standard LCG. You understand this? This part has a shorter period. So they remove this part by right shift 16 bits. Are you clear about that? Now, I think it's almost finished. I mean, 2 lectures for statistics or computer simulation is almost finished. I was very surprised that last lecture nobody asked me why do we have to learn about Monte Carlo, even when we are talking about traffic simulation. There are 2 reasons for that. The first reason is computer simulation is the basic of traffic simulation. And Monte Carlo is typically used in computer simulation, so we have to introduce it. And another reason is I want you to think about the application of Monte Carlo in traffic simulation. Because when you're doing simulation, you don't want to get chaotic results. You always want to get something out of the chaos so you can publish, so you can find a law or find a theorem, create a theorem. What is that? That's something that's the reason I want you to think about the law of large numbers. How is this reflecting any transportation phenomenon? So, and this class actually is continued on the last lecture. When you're doing Monte Carlo, you are using a lot of pseudo-random generators. And how can you tell the Monte Carlo result if you don't understand this? Now it's the homework 2. It's due at 5 p.m. next Monday. Okay, I'm going to tell you a story, okay? You are now responsible for developing a simulation model. So, you want to synthesize some drivers. And we assume each driver is represented by only 2 numerical attributes. Attribute 1, attribute 2. Then you have already collected data from 1,000 drivers. This is the data you can depend on. I'm going to show you. You have the data. You want to synthesize drivers. The question for you is, if you are required to create 5,000 drivers, what steps are you going to take next? And what? And I want you to prove that your result is a good match to the collected data. In one sentence is, you have 1,000 points. I want you to generate 5,000 points. And that's all. How do you do it? These are data points that you collected. So, data points. So here are 1,000 points. I will upload the data file in CSV format on UV-Lab. So I gave you 1,000 points. You find this is attribute 1. This is attribute 2. I plotted them. I want you to give me another 5,000 drivers. How do you do that? The most important thing is, no matter how you do that, you have to prove to me that your result is a good match to the collected data. How do you do that? Anybody has questions about my homework? Do you already understand that? If you don't understand, I can explain that. Feel free to ask me questions before you go home.
So we need to describe how we prove or we need to prove it.
You can describe or you can use programming language anyway.
So you just want a written answer then?
There's no right or wrong answer, but there will be some good answers and like bad answers. So you have to justify what you have done.
What is the bad answer?
Okay, let me give you a bad answer. The bad answer that I will immediately think about is I'm going to do a regression. So finally, you give me a regression of either straight line or curved line. And you tell me, okay, I have a function for you, f attribute 2. Attribute 2 is a function of attribute 1, and that's all. And in that case, you are only to give me a line. I don't want a line. I want 5,000 points. Okay. Because in that way, you are going to get only one line. You are not going to get more characteristic out of these data points. In that way, if you are doing regression only, you are going to lose a lot of useful information. You agree on that? Because let's assume we have a linear regression model. Okay, it's a good fit. But you won't be able to know that if there are more points here and less points there, or you have more points there and less points near it. You can, of course, you can provide this R squared, but I just don't want you to give me a function, regress function. So think more about that. Or in another word, I want you to generate 5,000 points that look like this using the existing 1,000 points.
Why not duplicate it 5 times?
Yes, that's a good answer.
So
That's a good, bad answer. Okay.
Yeah.
So if I want you to, it is, you can, yes, you can generate to duplicate it 5 times. But what if I want you to generate 5,001 points? Which one do you want to duplicate? Now what about if I want you to generate 500 points? Which half of them are you going to delete?
So Patrick's suggestion is one way, it's not the best way.
It's not the best way. You may
So that would be an
work for
example of
5,000.
an answer that's not too good and not too bad.
But I think it's a novel. It's novel. Yeah.
If you review your statistics and probability stuff, you'll be able to answer that. It has to do something along that line.
Okay.
And along the theme what Shan was discussing this lecture, in terms of the random generators and stuff like that, this is really how you could think about it.
Yes. You get a good answer. So this time you can either submit a CSV file to me, and a PDF to describe what happened, or you can just send me a PDF saying what you want to do. Some of you may not have the ability to programming, but you should have the ability to describe what you want to do. Okay.
So you could write it in pseudocode, like what the steps of what you would do it. You don't have to program it and generate the database itself,
Right.
the data points itself.
Yes. The methodology itself is the most important part. Okay, now it's the end of lecture, and this Thursday, I think it's a holiday, right? So don't come here on Thursday.
Are you going to do some notes? The slides?
Yes. Yeah, every day.